A dynamical system moves probability weight across its state space. Some states are absorbing. Once the system enters an absorbing state, it can never leave. This is not an approximation or a boundary condition. It is built directly into the transition structure of the system. Absorption is irreversible. Every structural result in this episode rests on that single fact. The absorption time is the first moment the system enters the absorbing set. Before that moment, the system is still active. After that moment, nothing changes. At every point in time, there is a clean partition. Paths that have been absorbed, and paths that have not. Every path falls into exactly one of these two groups. Survival means the path is still in the second group. Conditioning on survival creates a new probability measure. In that measure, absorbed paths receive zero weight. All remaining probability mass concentrates on the surviving paths. As time increases, the survival probability falls. The mass concentrates on fewer and fewer paths. This is not a correction of a measurement error. It is a change of the mathematical object you are computing with. When the absorbing value is zero, the conditional expectation is always above the unconditional one. Absorbed paths pull the unconditional average downward. Conditioning removes those paths entirely. Only higher value survivors remain. The law of total expectation makes this exact. The full average equals the conditional average multiplied by the survival probability. The inequality is structural. It follows from the definition, not from any model assumption. Taking the long-run limit outside the conditional expectation gives a different result than conditioning on survival first and then computing the limit. This is not a coincidence. The conditioning event itself changes as time increases. At each step, you are conditioning on a different event. The standard theorem for exchanging limits does not apply here. Behavior at large times cannot be read off from behavior at moderate times. The operators genuinely do not commute. In the gambler's ruin, absorption is certain for every path. Yet among the surviving paths, the conditional expectation rises toward the upper barrier. This apparent upward drift is pure selection. The dynamics have not changed. In a branching process where the mean number of offspring is below 1, extinction is certain in the long run. Yet among surviving lineages, the conditional expectation grows without bound. In both cases, conditioning describes the survivors. It does not describe the population.